Okay, so here we go using the viable system model to make organizational action research more sustainable. So the motivation here is that organizational action research is important and useful, but often difficult to sustain for political, technical, cultural, and other reasons. As is illustrated in this diagram here, there is a classical five-step action research method by Sussman and Everett, and it makes collapse at various stages. This is well known. So, trying to solve this problem, the Health Information Systems Program HISP developed something called a network of action approach, providing global infrastructure for action research so that the NOA, network of action, would sustain beyond a failure at individual sites, meaning that it looks at action research from the viewpoint of a network rather than individual cycles like that. So, however, when trying to which is a very good idea. However, when trying a similar approach for designing local action research in public administration, this has led to repeated failure over several years. So the purpose of this paper is to look at why this has been the case and try to use the viable system model by Stafford Bear in an attempt to reformulate the network of action approach in a manner that makes the network of action NOA easier to implement for general organizational action research. So here we have the network of action in the HISP case. In HISP, a network of academic institutions and non-academic actors have developed over a period of more than 30 years, as seen in this map here. Information systems action research with 3 research questions. So those are how to garner political and financial funding, how to develop information systems, and how to provide training and education. And these questions are interesting, particularly in the context of how this is the research is being carried out in developing countries in the global south. So we have these contextual challenges. So, final point, despite occasional action research failures at individual sites, the NOA continues to evolve and expand because it is a network, so it doesn't matter if one node explodes, it can develop in other ways. And the way this network is developed is by using something called the bootstrap algorithm. It looks like this, and it makes use of so the solution here that we want to develop is the information system. In the case of HISP, it's something called the DHIS, District Health Information System, or DHIS2, and these are formed as research hypotheses. The users are researchers and clients, and the practices are research and development. So where we start with this initial network. Start with simple, cheap, flexible solutions, small network of users that may benefit significantly from improved communication with each other only. Simple practices, non-critical practices, motivated users, knowledgeable users. And when we have this hopefully stable so-called installed base, something that is really working, and we want to expand on that. And then we have the steps 2 to 6. 2, repeat as long as possible, enroll more users. 3, find and implement more innovative use. 4, use solution in more critical cases. 5, use solution in more complex cases. 6, improve the solution so a new task can be supported. And as we see on the left there, in the case of HISP, the initial the install base starting was the University of Oslo in Norway and the University of Western Cape in South Africa. Those 2 nodes was the initial solution, and then we start to expand steps 2 to 6, expand and strengthen the global NOA by enrolling in other African countries, India, Latin America, Eastern Europe, and so on. Then we have the general idea here is that sustainability and scalability. So we want to we maintain sustainability by scaling upwards, by making it larger and larger. But how to spot challenges along the way? When do we know when how does the algorithm end, when we don't know how to stop it, and or does it stop by itself? How to spot challenges along the way. And the challenge here, as right on the bottom there, identity, vision, control, coordination, and productivity are indirectly communicated by politics of networks through actor network theory, ANT. What I mean by that is that when you look at what the challenge along the way are often of that particular nature, what is captured through actor network theory, but is not explicitly explained in the algorithm. It's something that's more like what can be seen between the lines, the way maintaining identity, vision, control, coordination. So that's why we came up with this idea of using the viable system model to rearrange the original bootstrap algorithm, or just to scaffold the algorithm by use of this Stafford Beer's viable system model. Just as before, the organization or the structure that we're focusing on consists of the solution, the network of the IS hypothesis as evolving, the users are the researcher and clients, and the practices, research and development. It starts just like on the previous version of the BA. It starts in a very similar way: activate productive operations. This is the VSM system 1. Start with a simple, low-cost and flexible solution that enables a small group of motivated and knowledgeable users to perform non-critical but meaningful work to produce tangible outputs. This is how we start, and then and as I said, the productive aspect has to do with doing research and development. But then we need to coordinate, we need to stabilize interaction. System 2. As use spreads, introduce lightweight coordination mechanisms that reduce friction between users and prevent interference while preserving local autonomy and momentum. You need to coordinate the research aspects by conferences and journal writing and collaboration with judges, and we need to coordinate and make the practical aspects. Then we have the system 3, which has to do with control, legitimize and resource success. When operational practices demonstrate value, extend their use to more critical, complex contexts by aligning them with existing management controls, resource allocation, and accountability structures. So here, not only do we need to make sure that, in the case of HISP, like the technical infrastructure is being controlled, but we also need to control the academic side of the aspect, like making sure quality papers are being written and published, and getting research funding and so on. Then we have next level. System 4, learn and adapt. Reflect on emerging practices to identify new users, but to anticipate future needs and improve the solutions so that it can support additional tasks and contexts. So on the practical side, talking about how the system and the information system can be expanded in different ways, but also we also have to look at the academic side, how to collaborate perhaps with different kinds of researchers, perhaps in the case of HISP, not only technological research, but also medical research, educational research, quality control research, and whatever might be useful for expanding and strengthening the network. Then finally, at the top there, reaffirm purpose and identity. Anchor the expanding system in a stable sense of purpose and policy, ensuring that growth remains aligned with external requirements and organizational identity rather than transient managerial fashions. So this is important both from the from the technical perspective, but of course also from an academic perspective, not following the latest fashion, academic fashions in theories, but also working on like something like systems theory, which has a long history and is very useful for dealing with practical problems. And then we have finally repeat recursively. So treat each expansion as a new system 1 unit within a larger viable system and repeat the cycle at increasing levels of scale and criticality, starting with individual competing groups and larger groups and nations, and as the whole thing grows. Now let's look at a practical. I want to illustrate this through a practical example, and as I mentioned, where we had some problems. And this is 6 years of action research. A network of action was developed inside the client organization, and there were continuous attempts to also connect with external networks. The on the right there, the bootstrap algorithm was used for researching and developing internal control. By starting with an installed base of existing internal control, there's always some type of internal control in organization, no matter how it's being run, and gradually expanding it. But in this case, the bootstrap algorithm eventually terminated for political reasons. Yes, which I discussed in more detail in the paper. Now, could we have predicted or prevented that? I believe so. That at least to some extent that could have been done if you had been using this viable system model for scaffolding the bootstrap algorithm and in the development of the NOA. If the alternative VSM-based BA formulation had been used, it seems likely that the process had evolved differently. Well, step 1 was successful despite client organization being hostile to research. So in this case, it was the same thing, step 1. Step 2, however, here we should have been more attentive on trying to focus hard on how to coordinate sufficiently with academia. The problem was, of course, that it was very difficult. The organization was difficult in itself, and much need for coordination within the organization, but that meant that the academic organization suffered to some degree at least, although there were efforts and the same problem with step 3. It was not so visible while doing it, but in retrospect, it's clear that the academic published several books and many papers during this period, but we should have been the quality of the outcome was not as good as it could have been. And then we have step 4. We tried but failed to connect with the HISP. That was a good idea to try to link with HISP, but as this organization was rather hostile to research, it was difficult to do it, and also then the branch or the node within HISP that we tried to link with collapsed, so we were unlucky in that particular case. And then we have 5 steps. It resulted in identity crisis and collapse. So that was a bit unfortunate. Discussion. The illustrated case tells a story about trying to do NOA-inspired action research in a hostile organization by executing the BA, which didn't work so well. Well, it lasted for 6 years, but it could have gone better. And then we have the VSM articulation of BA shows how the approach was not viable because the NOA was completely dominated by the client organization, meaning that the client organization was the owner of the NOA, which is a sort of a crucial point here. Who is the owner? Because in HISP it was academia that was the owner of the NOA. So if action research at a particular site collapsed, that would have minimal consequences for the NOA as a whole, and will allow action researchers to move to different sites. So at least it was good that it was owned by somebody, not that would make it possible to look at the client organization as a single node within the network, rather than to put everything there. So academia would be very useful. Conclusion: Action research makes it possible to investigate organizational sustainability strategies in real life, but it is a risky approach. As I said, then they have something like designing action research as a network of action by following the bootstrap algorithm increases the chance of success. So that's a very good thing, but it still requires attention to identity, vision, control, coordination, and productivity. So the research contribution here is using the viable system model, VSM, to re-articulate this bootstrap algorithm provides a means for making sure that the NOA remains viable through all stages of development. Thank you.